Now that we've done that, the second thing we're going to actually look at when we're trying to graph a polynomial, and we're going to pull this all together at the end and draw a few polynomials, is a thing called multiplicity of zeros. So let's have a look at this box here. Suppose that x minus alpha is a factor of the polynomial p of x. P of x is equal to x minus alpha to the power m times q of x, where q of x is not divisible by x minus alpha. Then alpha is a zero of multiplicity m. So what this tells me is that there's this term called multiplicity. That's what we're looking at here. Multiplicity. So if I can divide my polynomial multiple times by the same linear factor, it means it has a given certain multiplicity. So for example, if I have, e.g., p of x is equal to, let's say we've got x minus 2 squared and x squared plus 4x plus 1. What this tells, if you have a look at this first bracket, and here, what that power tells me, in particular this power, it tells me that x is equal to, well, for this factor, it's actually x is equal to 2, is a zero of multiplicity 2. The power of that zero of that linear factor tells me what multiplicity it has. So the multiplicity is just what power does each factor have. So for example, another one, let's do another one just to show you. So if p of x is equal to x minus 1 to the power 3, and there's like x minus 2 squared, x plus 1. So what this tells me, and let me just break down each part. So x minus 1 tells me that x is equal to 2, x is equal to 1 I mean. X is equal to 1 is a zero of multiplicity, that power 3. Next one is this part here. So we've got x is equal to 2 is a zero of multiplicity 2. And the last one, and that term, that's what this second dot point is. A zero of multiplicity 1 is called a simple zero. So x is equal to minus 1 is a simple 0. That's what multiplicity is. I've just gone through it a little bit quickly because it's not too, you don't need to get your head kind of like too confused about this. It's just what's the power of that factorized out 0, and then that power will tell me what multiplicity is. The reason why this is important when we're graphing polynomials is because the multiplicity actually tells us what the shape of the polynomial will look like at that 0. So here, suppose x is equal to alpha is a zero of polynomial p of x. If x is equal to alpha is even, the curve is a tangent at the x-axis at x equals alpha. It's called a turning point. If x equals alpha is odd of at least 3, then the curve is tangent to the x-axis at a, but crosses the x-axis, and it's a horizontal inflection. And simple 0 means it crosses. Now, this is a lot of information, and you might want to read through it a few times. It's actually in that booklet, but I'm just going to show you visually what this looks like. Now, I'm going to start from that third dot point. If x is equal to alpha is a simple 0, so it has a multiplicity of 1, the curve crosses at the x-axis. So what this actually looks like is if I'm drawing my polynomial and I know that I have a zero of degree of multiplicity 1, or I have a simple 0, what happens is my curve will just cross at that point. So simple 0 at alpha, so it crosses the x-axis. That's what that third dot point there tells me. Now the second dot point deals with the first dot point deals with even multiplicity. So even multiplicity, so for example, if you have x minus 2 squared or x minus 4, or x minus, let's do another, put an odd number in here, x minus 1 to the power 6. If you notice the power, we're looking at the power, that multiplicity there. Now if it has an even multiplicity, it's tangent to the curve and there's a turning point. Now what this kind of looks like, it kind of looks like a quadratic function or a quadratic. So what happens is, when we have alpha, let me do this in a different color. So for example, what we have here is when we at alpha, it's going to come close to the curve. It's going to touch it briefly and only touch it at that point and then go back up. So this is at alpha. So this is a turning point. So if your 0 has even multiplicity, it's going to form a turning point. It's going to go down towards that 0, touch it at the x-axis, but not actually cross it and then go back the same direction. Okay, That's the next one. Now the final one is odd multiplicity. Now odd multiplicity results in this thing called a horizontal inflection. And this kind of looks like a simple cubic. So if I was to draw it, it would look something like this. This is a point, I think it's a horizontal point of inflection in particular. Horizontal point of inflection. Now this is actually a tangent, so it actually only touches there's a thing that we'll look at a little bit later when we look at calculus to explain this in a bit more depth. But here, it's a horizontal inflection. So this is odd multiplicity greater than 3. Let me just make that very specific. It has this weird kind of like S-bend kind of shape. So that's what a horizontal inflection looks like, a horizontal point of inflection looks like. And these three shapes are actually going to determine what your polynomial looks like around the x-axis at those zeros. So that's